Hi everyone, welcome to week 11. The goal for this week is to learn about infinite sequences and series. To do that, we're going to have an introduction to look at how some things can go wrong if we do not have a very nice way of talking about infinite sums and infinite sequences. The starting point is something called Zeno's paradox of motion. It's a bold claim that says that no motion is possible on the ground. And that's obviously untrue because we can move. And here's the proof. Suppose you want to travel from A to B. To do so, you must first reach the halfway point between A and B. Let's call that B1. And again, to reach B1, you must reach the halfway point of AB1, say B2. Basically, the finite distance AB can be broken into infinite, finite smaller steps. The argument is that it would take infinite time to perform an infinite number of operations, therefore, no motion is possible. However, later on we're going to see that what the series defined by Zeno's paradox is what we call convergent, and so even though it's an infinite number of operation, it adds up to a finite number. In response to Zeno, Diogenes was another learned person. He just walked across the street to prove him wrong. We're going to resolve this paradox later on. Again, it's basically learning how to add infinitely many things without breaking certain rules or being consistent. The second example is called Ramanujan's summation. The sum here, the word summation here is not in a traditional sense. It's something that was developed by Ramanujan without much explanation in his notebook. Okay, the first claim is that 1 minus 1 plus 1 minus 1 plus 1 minus 1 up to infinity is 1 half. Now that seems pretty crazy, but we can prove it right here. And you've seen this method in a worksheet bonus problem. Let A be the sum, A1 minus 1 plus 1 minus 1 and so on. Then A can be written as 1 minus 1 minus 1 plus 1. But what's inside here, that's basically A. So rearranging, I can have 1 minus A is A, giving me A is 1 half. Now this is a proof, but it seems crazy that you add whole numbers and you get a fraction, right? Actually, we'll be seeing even crazier stuff using this right now. The second claim is that if you take the numbers with alternate plus minus, 1 minus 2 plus 3 minus 4 plus 5 minus 6, it equals a quarter. Again, that seems ridiculous, but we can prove it. Let B be this sum. And remember A from before? Do an A minus B operation. And then you recombine them. So you have 1 minus 1, that's the first terms, you have negative 1 plus 2, you have a plus 1 minus 3 and so on. What you end up is with B again. So A minus B is B, or B is A over 2, which becomes 1/4. Again, seems crazy, but we are able to prove it in this particular definition of summing things. Now that we have these two sums, 1 minus 1 plus 1 minus 1 to infinity is 1 half, and 1 minus 2 plus 3 minus 4 to infinity is 1/4, we make this very bold claim that looks absolutely absurd, which says that if you take all the natural numbers and you add them, their sum equals negative 1/12. Now this should ideally make no sense because you're adding a bunch of positive numbers and you get a negative number and it's a fraction. Again, there's a way you can prove this technically. B minus C, let C be this series or this summation, and B from before, and then we rearrange. So we have a 1 minus 1, we have a negative 2 minus 2, a plus 3 minus 3. So the odd values all cancel out. So I'm left with a bunch of even numbers. But if I factor out a negative 4, what's inside? That's C. So B minus C is negative 4C, or B is negative 3C, or C is negative 1/3 of B, which is 1/4, which gives me negative 1/12. Now, in the course of this week, we'll understand why such weird things happen and how to make sense of the math behind it. So this is the motivation for being able to correctly define what happens or what we mean by adding infinitely many things, or what does it mean for um, infinite sums, what they mean. That's it. So we'll start with definitions in the next video.